Hi there, thanks for joining us and Happy New Year. This is Space Nuts. I'm your host, Andrew Dunkley. Great to be back again, and I hope you had a terrific Christmas, New Year period. If you got to have a bit of a break, goody for you. If you had to work, nothing more needs to be said. Coming up on this episode 386, we're going to look at the Peregrine moon lander, which was launched just recently, the other day, but it looks like they've run into a mission failure problem. We'll also be talking about the lost grave of Copernicus, more specifically, the lost Copernicus himself. And they think they found him. And what are those islands that come and go on Titan? It's a bit of a mystery, but they think they've figured it out. We'll also be looking at audience questions about quantum entanglement, why the inner planets are rocky and rolly, and the unknown solar system. All to come on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me to disassemble all of that is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. It is very good to see you again, and Happy New Year, and hope you had a great festive season.
Did indeed. Went on a cruise, visited Fiji, Vanuatu and Noumea, had Christmas Day in Noumea, and we only found out when we got there that the French celebrate Christmas the day before. So there wasn't much going on, but we had a good time. It was mighty hot, but we had a nice lunch on the beach there, which was good. And one of the weirdest things we did was in Fiji at Lautoka, where we went and visited some hot springs and got covered in volcanic mud. And then got into, what's the dumbest thing you can do in Fiji in summer? You can get in water that's 60 degrees. So that's what we did. And it was a lot of fun. But, and smooth seas all the way. So we were out on the water for 2 weeks and hardly saw a wave, which was terrific, especially this time of the year. I mean, cyclones have been all over the place, but we managed to miss all of that. How was your Christmas?
Pretty quiet. We had family, friends, and everybody round on several occasions, including my 2 sons who came and had a lovely Boxing Day with us. But I had my head down for most of it, trying to finish an article that has been hanging over my head for 3.5 years. So I did finish it, and the good news is it's finished. The bad news is that it's 50% too long, and so I've got to start chopping away at all this work that I've done. So it's an ongoing story. In fact, I wonder when this story will ever end.
Yeah, that's a slow burn, 3.5 years. Good grief.
It is. It's pretty shameful, actually. Pretty shameful.
Well, they should have given you a deadline. That works in radio, I can tell you.
They did.
Oh, dear. Okay, Fred, let's get stuck into it because we have a lot to talk about for our first official show back for 2024. And let's start with this unfortunate situation that seems to have struck the Peregrine moon lander. It was launched on a brand new rocket just the other day. It looks like the rocket launch was okay, but then when they released the spacecraft, and this is a civilian effort. This was going to be the first civilian touchdown on the moon. And now it looks like it's not even going to get there, but it was launched on the Vulcan Centaur rocket, which is the next big thing.
Quite right. It's a story that, as you say, got off to a great start and is full of promise and all kinds of interesting aspects to it. But it looks as though it's in big trouble now. And the really interesting thing about it, first of all, exactly as you've highlighted, Andrew, what we have is the first launch of the United Launch Alliance's new Vulcan Centaur rocket, which is a replacement for their older version, and that performed flawlessly. United Launch Alliance is basically a collaboration between Boeing and Lockheed Martin, and is one of the I guess, the two big players in American launch vehicles. So that performed flawlessly. The Peregrine lunar lander itself, exactly as you've said, it is a private enterprise. NASA is trying to actually devolve a lot of its development and production work on issues that you might consider relatively straightforward, like sending probes to the moon, to the private sector. And that's in that regard, I do note that NASA, in commenting briefly on the fact that the Peregrine lander seems to have run into trouble, kind of shrugged their shoulders and said, yeah, that's kind of what we expect with, such a new idea of putting the private sector on top of these projects. But it will lead to better understanding of what the issues might be. So what happened? We're not really exactly clear yet what happened. The first problem was that the mission controllers discovered that they couldn't turn the spacecraft to point its solar panel at the sun and to charge up the batteries. And that was a real panic situation, because you don't have that long on the onboard batteries for them to provide power without being actually resupplied by solar energy. And so, yet the sun... the sun pointing exercise turned out to be a lot harder than they expected. And that was the first alert to the fact that there was a problem. They managed to do it, but then realized that they had a serious propellant loss, which, I'm not sure whether they know how that's happened yet. But they've described it as a failure within the propulsion system that's causing a critical loss of propellant. Trying to stabilize the loss, but given the situation, they have prioritized maximizing the science and data they can capture. In other words, looking at what they can actually do with a spacecraft that probably isn't going to make it to the lunar surface, because they don't have the fuel needed to make a safe landing. Just very briefly, I know we were just, this is just an update, but the spacecraft is interesting because it carries a number of NASA experiments. They've funded the mission essentially, but also has some little miniature rovers, which I think have come from the Mexican Space Agency, and also what might be called, what are called CREMS capsules. These are little capsules containing the ashes of humans. So it's taken some ashes to the moon. That was the plan. And it was a plan that had turned controversial because the Navajo Nation in Arizona in particular are upset about the idea of human remains being placed on what they consider to be a sacred object, the moon, in their tradition. And so that produced some controversy, which has not really been resolved. But if the spacecraft doesn't make it to the moon, that solves that problem. And that seems like the likely outcome at the moment.
Yes, and I suppose that there's more controversy now because with human remains on board and planning to put them on the lunar surface, they won't get there now. So what happens there? I'm guessing that the propellant loss has been because of some fault with the lunar lander itself, or there's been some damage as it was taken out of the payload. Who knows? I guess they'll try and figure that out. But they're now trying to see what can be salvaged in terms of things they want to achieve on this particular mission. I was surprised when you said that NASA kind of expected there'd be issues. So why would you, knowing that things might go wrong, why would you still go ahead and put your stuff on board now knowing that it'll probably not reach its destination?
I don't. I think they were. That's taking it a little bit too far. I think it's more that they were philosophical about the fact that there was an issue. They didn't expect it, but they understand that they're doing something so new that that private enterprise is very capable in particularly in the USA in terms of the space industry. But there's always risks attached, and perhaps what's different is that NASA is an extremely risk-averse organisation, as you might expect, especially when human life is involved, and eventually it will be with the Artemis missions. In fact, we've learned this morning that they pushed those back, so we're not going to see Artemis 2 until probably late next year, and we're not going to see Artemis 3 until 2026. So that's not unexpected, but that comes from, the fact that when you've got humans, you cannot, you can't take risks. No. Whereas, I'm sure they've been risk averse with the Peregrine mission, but as I said, they're more philosophical about the fact that things haven't gone according to plan.
Well, let's face it, sometimes things do go horribly wrong. Sometimes it's only a small problem, but it can create big issues with trying to get things done. Let's hope that they can piece together some sort of salvage job on this and achieve something. But landing on the moon looks like it's been lost to them, unfortunately. But we will watch with interest and hopefully have some positive news in the aftermath of the Peregrine moonlander issues. Let's move on to this next story. This is an amazing story about the search for the remains of Nicholas Copernicus, the great astronomer and mathematician who, came up with an idea and wasn't real keen to make it public because he was worried about the backlash from the church and other scholars. But it brings me to that great Copernicus joke where his mother said to him, "Someday, my Nicky Copernicus, someday you'll learn that the world doesn't revolve around you." And and that was basically what he wanted to prove, that Earth was not the center of the universe and everything revolved around us. But the search has been on for his remains, and even Napoleon wanted to find him because he held Copernicus in such high esteem. So tell us about this amazing story of the search and potential discovery of his remains.
Yes, that's right. So he died in Frombork in Poland in 1543. He actually died just about the same time as his great book on the on the revolution of the planets around the sun. De Revolutionibus is what we call it. That book was basically published while he was on his deathbed. So he did see it, I think, but then passed away knowing that his great work had been put out there for all to see. What surprised me about this story, Andrew, is that while he was alive, he wasn't really known as an astronomer. He was a mathematician, but he basically put that mathematical knowledge into economics. And he developed theories of economics, which still kind of hints of them are still, visible in the work of great economists like Milton Friedman and people of that sort. So his ideas were very far-reaching. The Copernican model doesn't actually owe its true origin to him, because there were Greeks who put the sun at the center of the solar system. Nobody believed them because Ptolemy was so great a scientist. Ptolemy was the person who said, of course, the Earth's at the center, and that was what we call the Ptolemaic system. But by the time Copernicus was a thinking man in the 1530s and 40s, he'd got the other end of the stick that's the wrong way around. It's the sun that's at the center. So he passed away, as I said, 1543, in the cathedral at Frombork in Poland. And a few people have tried to identify his remains within that cathedral, because there's about 100 graves in there. Most of which are basically unnamed. They're graves without anybody's name on them. And so, basically, there's been a long history. And as you said, it included good old Napoleon thinking that it would be good to try and find Copernicus's remains because of his admiration for Copernicus. So fast forward to 2005. And I think you and I might have covered this story on the radio when you used to be in charge of breakfasts in the Western Plains of New South Wales.
Yeah.
It was a group of Polish archaeologists who picked up the thinking about where Copernicus might be. And because Copernicus had a relatively elevated position within the cathedral, he was the canon of Frombork Cathedral, they made the fairly logical assumption that he would have been buried near the altar, which he was responsible for while he was serving, and so sometimes known as the altar of the Holy Cross. They found there were 13 skeletons near this altar, including one that was incomplete, belonging to a man aged between 60 and 70 years, and that actually matched Copernicus's age better than any of the other skeletons. So they took this as being likely to be Copernicus's skeleton. And what they did was they took the skull and they made from that a facial reconstruction. And I think that might be what you and I would have talked about back then in the early 2000s.
Yeah.
Because I still have a picture of that facial reconstruction on my laptop. And so that was where the story sat. But there was a further step that took place not very long after that. Because, of course, what you want to find is DNA. A DNA analysis is actually the sort of gold standard in this regard. And so it turned out that the skeleton that was proposed to be of Copernicus had very well preserved teeth. And so they could use that the material from his teeth, to essentially do a genetic scan, a genetic, identification. And that's all well and good. But in order to really pin it down, you need to know the genetic material of somebody who was related to Copernicus.
And there were none.
There's nobody who fits the bill of that. But then it turns out, and this was actually just a couple of years after that facial reconstruction, they found that these Polish scientists, in a book that had been taken to Sweden, that Copernicus used, a reference book that Copernicus used, it had been taken to Sweden apparently in the middle of the 1600s, and is actually it resides in a museum that I've visited, the Gustavianum at Uppsala University. It's a marvelous museum. If ever you're in Uppsala in Sweden, it's well worth a visit. Stunning collection. So this book is actually in the Gustavianum, and they kind of went through it with a fine-tooth comb, and that's an appropriate metaphor, because what they found were hairs. Hairs in the book that probably belonged to Copernicus. And so, to cut to the chase, they actually could extract genetic material from these hairs and compare them with what they'd got from the teeth, and actually some bone samples as well from the tomb. Compare them, and what did they get? They got a match. And that's such a strong suggestion that this is actually the skeleton of Copernicus, that I think, the world of science history is really celebrating a breakthrough of this because of this result. So it is an extraordinary outcome, an extraordinary finding, that modern DNA testing can give you basically a pretty solid identification of somebody who's in an unmarked grave with no known relatives. It's quite extraordinary.
It is amazing. And when you really analyse it, that particular book that they found the hairs in was a war trophy. Sweden had invaded Poland in the mid-17th century, and they took the book back as a piece of war booty, and that's how it ended up in Sweden. And they found those hairs, and they've cross-referenced them, as you said, and the odds of someone else being buried in that cathedral that read that book as well are very, very low, I would imagine. So it almost confirms his identity, almost absolutely. You just can't say 100%.
Well, that's right. You never can with these things, but it's very, very compelling evidence. Actually, you've just reminded me that there's another connection with modern-day Sweden, which certainly I've been involved with, because one of the fantastic tourist attractions in Stockholm is the Vasa, which is a sailing ship that was built by the King of Sweden to go and basically join in the battle for Poland.
Yeah.
And on its maiden voyage sank in the harbour in Stockholm, was dug up in 1961 or raised, and is in the most astonishing museum. It is such it's absolutely awe-inspiring to walk in and see this 17th century vessel. It's huge, towering above you, looking as though actually it's made of Easter egg chocolate, because because the preservative that they use to protect the wood. Now it's dry.
Do you know why it fell over?
Yeah. Because the king wanted an extra layer of guns in the lower deck, so the gun ports were open, and it heeled in the wind, and the water came in through the gun ports.
I heard I don't know if it's the same ship, but I heard a theory that during construction there was confusion over the weights and measures process, and one group of tradesmen used one system of measure and someone else used another, and the thing was actually built with a lopsided weight distribution, but I don't know if it's the same ship.
That might have been partly it as well.
Yeah.
Could be.
But it didn't last long. I mean, it pretty well, it didn't even get out of the harbour and gone.
No.
Very sad story, that one, but great news that they have probably identified Nicholas Copernicus. Do we know what will happen with those bones now? Are they just going to leave them there? What happens?
I think so. I think they would have, reburied them. They've probably been there for the last nearly 20 years after they took the samples.
Okay, fair enough. All right. Fascinating story, and one with a happy ending, I suppose. You're listening to Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we're off to Titan, and this is a place you really don't want to go on a hot summer's day for a swim. It's a pretty hostile environment, but it's also shrouded in mystery because they've been sort of, I'm guessing through radar images, seeing stuff floating in the ocean and then disappearing, and they thought they were probably ghost islands at one stage. But now they've got a new theory, and this one sounds like it might hold water or methane, as the case may be.
That's right. So just to recap on this, we talked about this a lot at the time. And these are results from the Cassini mission, which ended in 2017. And one of its great triumphs was a mapping, essentially, using radar of Saturn's largest moon, Titan. Titan is one of the most extraordinary worlds in the solar system because it's the only place in the universe other than the Earth where we know there is liquid on the surface, a liquid which is in equilibrium with its atmosphere. So Titan has a thick atmosphere. If I remember rightly, its atmospheric pressure is about 100 times what we have here, a bit like Venus. It's mostly, if I remember rightly, mostly carbon dioxide, but has within it, because the temperature out at the distance of Titan is typically minus 190 Celsius, there is a sort of rain cycle on Titan, which is because it's got methane and ethane, and they are basically go between a vapor and a liquid state. And so there are lakes on the surface of Titan, which, by the way, is not rock, it's solid water ice, with a layer of liquid water underneath it. It's an amazing, absolutely amazing place. And NASA, of course, has plans to launch another helicopter to send there to Titan, something called Dragonfly, which I'm sure you and I will talk about when Space Nuts is in its 400th, in its 5th century of editions. In the 400s, yes, that's right, of episodes. So one of the puzzles that came from the discovery of these lakes, and I should say they were discovered by the downward pointing radar carried on the Cassini probe, what you do is you beam radio waves down to the surface and look at what they look like when they come back. And if you've got a dark reflection, then what it tells you is that your radio waves are bouncing off something very smooth indeed. If you've got a bright reflection, they're coming off a rough surface. And so by using that technology, the NASA and ESA mission scientists were able to map these lakes and seas, which are predominantly in the northern hemisphere of Titan. There are one or two in the south. And the only liquid that can sort of survive under those conditions is a mixture of methane and ethane, and that's what the atmosphere contains. We know that from spectroscopy. So the seas were well mapped, and they've got names. Kraken Mare, I think, is the biggest, which is in two halves with a narrow gap between them, which is called the throat of Kraken. It's great terminology. But one of the mysteries that came up, well, there are two really. One is that you can use the radar, Andrew, to measure how smooth the surface of this liquid is. And it turned out that the biggest waves on it are a matter of millimeters high. They're not waves like the ones we see on Earth. They are tiny. And we don't really know why that is. There is a suggestion that it might be because there's a thin layer of ice covering these seas. But that's, there's something that remains to be seen. But the other thing that was detected by Cassini was what you've termed magic islands or ghost islands, which are bright patches in the seas that come and go. I think they come and go over a matter of days, in fact. And so the question was always, and this was a question that was left unanswered, excuse me, by the Cassini mission. Those islands were discovered first in 2014. And they move on the surface, but they disappear as well. So they appear and move around on the surface and then vanish with time intervals. I said a few hours or days, a few days. They can last just hours or even several weeks in occasion, but they were all temporary. And so the thinking about what they were at the time were, well, first of all, temporary icebergs made of perhaps frozen ethane or methane. And that's actually close to what the new theory suggests. But another theory was that they were actually ripples on the surface. If you've got a wind blowing on the surface that causes it to ripple, then that will make the surface look bright in a radar reflection. And so, ripples have been put down as being one of the possibilities as well. Anyway, cutting to the chase, there is a new study that suggests that there may be organic chemicals, which are actually what ethane and methane are, but perhaps several different species of organic chemicals. And the article, which is on phys.org, one of our favourite websites, that actually lists many of these different potential organic solids, which they think might have condensed sort of out of the atmosphere. And wonder, because they've looked at the contents of the atmosphere as well as the contents of the liquid lakes to try and figure out what they might be. And so what they're saying is there might be solid materials deposited out in the atmosphere which could float for a while before eventually sinking. And they wonder whether, these things might have an interesting structure. They actually suggest they might be a kind of almost like a honeycomb structure. They actually come to that conclusion because if you've got this sort of honeycomb, then it takes a while for the liquid methane to seep into it so that the thing would then sink. So a honeycomb would allow it to sit on the surface for a longer time. Interesting stuff, which is still, I guess, theoretical, but as good an answer as I think we're going to get in the post-Cassini era. And it may well be that when we send new spacecraft to Titan, which I hope will happen while Space Nuts is still on air, then we might get more answers.
Yeah, it is rather interesting, and it also adds more reason to not go swimming on Titan if stuff's falling into the ocean and crack you on the head.
Yes, that's right.
Not a pretty... it's a fascinating place, but not for the faint-hearted. Indeed.
That's right. Faint-heartedness is not something that will take you to Titan.
No, not at all. All right. If you do want to read about it, it's on the phys.org website. There's so much we just need to learn about the solar system, let alone what's happening elsewhere in the universe. And, almost on our doorstep, there are places that are so alien and so much to learn about. We do need to send more missions out, and that's exactly what's happening with Titan. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, let's tackle some audience questions, and our first one comes from an old mate who regularly sends questions into us, Rusty from you-know-where.
Hello, Fred and Andrew. Andrew and Fred. It's Rusty from Donnybrook. Refractive index describes the speed of light in a medium. So in a vacuum, the refractive index is 1 and the speed of light is c. In glass, it's about 1.5. So the speed of light is reduced by dividing c by 1.5. And in water, it's 1.3 and so on. So you do get these different optical media which are all slower than a vacuum, the vacuum of space-time. But then we come to quantum entanglement, and messages somehow go outside of space-time and can reach any distance where the 2 entangled particles are separated, and it's instant and requires no energy. So my question is, with an effective refractive index of 0, although it's not light we're talking about, do you think it's that every particle in the universe would have some component outside of space-time for this to be able to occur? And if so, do you think we should be doing a heck of a lot more research into it? Thank you, guys. Cheers.
Wow. He always comes up with a perler, doesn't he?
Yeah, it's so entanglement's a very, very intriguing, an intriguing phenomenon, which some people say defies relativity because it looks as though information is transmitted faster than the speed of light. But the quantum physicists themselves say that's a naive interpretation, and it's not what's happening. It's more that you have a correlation between the entangled particles, and so there isn't any way of somehow twisting it to make faster than light communication. Of course, it happens, and we know that there is a phenomenon. But I think it's one that's been misrepresented a lot of the time, and you can probably tell I'm struggling to explain it because I'm a bit hazy about the actual mechanism that are correlated. This idea of the correlation brings up. I have read a very good piece which I might check again about this, exactly what quantum entanglement entails, and it's not faster than light transmission. I'll check through that once we're off air, and maybe try and talk about that a little bit next time. I love Rusty's introduction to this because he's absolutely right. The speed of light varies depending on what medium you're in, and it's certainly possible that there could be additional dimensions that we're not yet familiar with. And there is a lot of research being done on that in the world of fundamental physics. It's one of them is work, the idea of dark matter and dark energy, which are quantities that we are familiar with in astronomy because the evidence is all there that they exist, but we don't know what they are. Some of the theories as to what they might be require additional dimensions that we have not yet discovered. And that's one of the things that's I suppose, propelled a lot of work at the places like the Large Hadron Collider, the giant atom smasher on the Swiss-French border. That collider has not yet, despite I think it's still at 14 tera electron volts is its maximum energy. It hasn't shown up any evidence of anything that could be interpreted as needing new physics. And so what that means is they haven't worked out what dark matter and dark energy is yet, but at the same time, they haven't found anything that needs higher dimensions. But that work is ongoing. Exactly as Rusty suggests, there's a lot of effort being put into it. We'll try and keep everybody up to date. But I will check out quantum entanglement again, because it's something that it annoys me that I can't put into simple words why it isn't faster than light transmission.
Okay, but that's what people are confused into thinking. Is that what you're saying?
Yep.
Okay.
Yes.
It is very confusing. But when you put the word quantum ahead of anything, you know you're going to have a complicated situation. All right. Thank you, Rusty. Let's move on to our next question. This one is a text question from Johan Sputh. Johan is a patron. And thank you, Johan, for supporting Space Nuts, which anybody can do if they want to. All the details are on our website. But, he's got a pretty simple question. I'm not sure it'll be a simple answer because our solar system doesn't seem to reflect that of many other solar systems. But he says, how come just the inner planets have rocky surfaces? For instance, why aren't Jupiter and Neptune rocky planets? Or put differently, why don't the inner planets have a large gaseous envelope above their rocky surfaces? Thanks, Johan. Interesting question. Is there a simple answer to that one, Fred?
Certainly, people who look at the theories of the origins of planets think they know the answer.
Oh, well.
And they're the ones I listen to. So, just going back to, planetary formation 101, we've got a young star which has around it a protoplanetary disk, a disk of gas and dust, which is swirling around, and the bits of material are colliding with one another and gradually building up bigger bodies. So you get planetesimals and then protoplanets and eventually planets by this process of accretion, things sticking together. But the critical thing in the case of the solar system is where that happens. And so the thinking is that on the inner edge of the solar system, the inner part of the solar system where the rocky planets are, the temperature, because of the solar radiation, is high enough to prevent the formation of ice. Whereas beyond that line, which is called either the ice line or the frost line, you get water ice forming. Now, water's critical to this process because, first of all, it's the most common two-element molecule in the whole universe. It's everywhere. And so it would have been in the solar nebula and also in the protoplanetary disk. The solar nebula is the cloud of gas and dust from which the sun was born, or in which the sun was born. So you've got water, basically vapor, which when it's within the frost line or the snow line is vapor, and it's vapor at the distances of the rocky planets. But when you get beyond that, it can freeze out and form ice. And so the thinking is that the planets that were formed beyond the frost line could actually accrete more material. They got bigger because they were able to collect ice. And so they probably have very icy cores deep down somewhere. And then because of their increased mass compared with the rocky planets, that means they were able to hold on to a gassy envelope until the present time. rather than losing it, which might well be what happened in the case of the inner planet. So they've got their gassy atmosphere and a much bigger, a much more massive ice core. That's the thinking. It makes a lot of sense. It is certainly very neat and tidy that we have 4 rocky planets and 4 gas giant planets beyond them. And it's certainly true that the frost line exists between the orbits of Mars and Jupiter. So it seems to be the correct answer.
So why then do we have rocky dwarf planets beyond the 4 gas giants, or are they ice planets?
Yes, they are. They're ice planets, most of them. A true ice planet would be a comet, in the sense that comets are just basically, small blobs of ice. But we think that so by the time you get to the distance from the sun that the dwarf planets are, and we're thinking of objects like Pluto and Eris and Makemake and Quaoar, all of these are trans-Neptunian objects. Small objects, they're small because at that distance there wasn't much left of the protoplanetary disk to accrete objects. You couldn't make something big at that distance because you were running out of material, and all that was left really was ice, mostly ice. And then if you look further out, you come to the Oort cloud, which is just a cloud of icy bodies, which we call comets, which are probably the leftovers of the extremities of the cloud of gas and dust from which the sun formed.
One more question, though. We are looking at our solar system, which, when we now analyse other solar systems, ours doesn't seem to be typical, because there are gas giants close to their parent stars, and there are rocky planets beyond certain limits. What makes the difference? Is it the type of star that seems that could cause that variation?
It's a good point, actually, that, we've not found a neat and tidy analogue of our solar system anywhere, partly because small rocky planets are very, very difficult to detect. And so, most of the 5,000 or so planets that are now known are big ones, bigger than the Earth. There are Earth-like planets known. There are ways of detecting them, but for a long time, all we were finding was the Jupiters. And yet, you're right, hot Jupiters are very, very close to their parent stars, and they're hot. So the thinking, I think, is that certainly in the case of some stars, you've got a lot of mixing of orbits. If you've got, something that gets disturbed by another star passing by, then it can toss a planet out of its orbit into something much different. But that is still one of the puzzles, though, of modern astronomy as to why we see this enormous variation in where planets are formed. And a neat and tidy solar system like ours seems to be a rarity.
There doesn't seem to be a standard model at all. So,
that's right. Not a standard model.
Maybe they'll figure it out one day. But there you are, Johan. It's because that's the answer to your question. Just the way it worked out, basically, because of that frost line. Thanks for your question. Lovely to get that one from you. And we've got one more question from Ralph, who is a regular sender-innerer. I've always wanted to say that.
Hello, Master Nuts. This is Ralph in Northern California. Thought maybe I'd throw another quick one at you since it's an all questions episode coming up. Recently, Fred was talking about Planet 9 and the possibility of something out there that's aligning the planets, or some force that we hadn't reckoned that is there in our solar system. And it got me to thinking, we take it for granted, at least we lay people do, that our solar system is well mapped and everything is accounted for and we know it inside and out. But it almost seems now that we really don't. Is it possible there's a lot more to our solar system that we realize? Just thinking it through. Thanks, guys.
Yeah, it's a good question, Ralph, and correlates well with the previous question in some respects. But yes, is it possible that there is stuff out there that we haven't discovered yet about our solar system? Things we just haven't been able to detect or identify or may never know about?
Well, yes, it's right. And Ralph, that is a great question. What it isn't, Andrew, is things hiding behind the sun, which is a popular conspiracy theory. The stuff on the other side of the sun from the Earth that we can't see is not that, because we've got satellites around there. Certainly the solar system out to the orbit of Neptune is well mapped. And it's with the modern technology that we have, the telescopes that are available, it will be very hard to miss anything. And I guess the fact that we're talking about detecting asteroids down to just over 100 meters across, and things of that sort, that's telling you how well we know the inner part of the solar system. Of course, it depends on how near those asteroids come. But the further out you go, the fainter the light or whatever it is that's being emitted, radio waves, the fainter they are. Radiation follows what's called the inverse square law. So if you've got a planet that's out at the distance, twice the distance of Pluto or something, then the amount of radiation that falls on it is a quarter of what falls on Pluto. And coming back to Earth, it's a quarter of what the reflected light from Pluto is. So you've got this, diminishing returns, and it may well be. We think there's a population of icy asteroids, the trans-Neptunian objects, which we know several thousand of. They've been mapped, but there must be many, many smaller ones that are too faint for us to detect. You might remember when New Horizons succeeded in its mission to fly by Pluto back in 2015. It carried on and had a rendezvous with an object which we called Ultima Thule for a while, but it has a different name, which is eluding me at the moment. It will come back to me, which is basically two saucer-shaped objects stuck together, an extraordinary thing. It looked like a snowman when it was first discovered, and that's a tiny object. I can't remember its dimensions, but it's of order a kilometre. I hope you're going to tell me what its modern name is.
Now I'm just trying to look it up. I've got a reference here to 486958 Arakoth. I don't know. Yeah, that's it.
That's the one. Arakoth. Yeah,
Arakoth.
That's correct. So that's what Ultima Thule eventually was called. And that's a tiny, tiny object. And I can't remember its distance. It's something like 6 or 7 billion kilometers. Let me just think that through again. Am I talking rubbish? It's certainly, Neptune. Well, let's do it in the normal units, which are astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. That's 150 million kilometers. Neptune is at 30 astronomical units, and we're finding things at 60 astronomical units. They've got to be pretty big and bright to shine at that distance.
44.
But that's
44
where we
units.
think Planet 9 might be hiding. Yeah, there you go. 44 astronomical units. That's Arakoth, is it?
Yeah.
44 astronomical units. Yeah. Good. There you go. And that's a tiny object. So we're doing pretty damn well, is my point. But at those distances, there are probably many smaller bodies that we simply haven't found yet. And it is just possible there might be another planet, but it's so far away that it is very, very difficult to detect.
Yes, indeed. But the search continues, of course. So, Ralph, I suppose there's stuff still to be discovered, but what we're piecing together about our solar system is a pretty big encyclopedia's worth now. So we're getting there bit by bit. Ralph, lovely to hear from you. Thanks for your question. And don't forget, if you do have questions, whether or not they're for an all-question episode or not, Ralph's was designed to be, but we didn't get to it in time, but it was still worth running with. Yeah, send them to us. You can do that through the Space Nuts website. Just click on the various links. There's the send us your questions link on the right-hand side, or you can click the AMA tab, and you can upload a text question or an audio question. As long as you've got a device with a microphone, you're all set. Just don't forget to tell us who you are or where you're from. And have a look around while you're there. Maybe sign up to be a patron if you are interested, and visit the Space Nuts shop if you like, and see what's available. Some good stuff, some great books in there by a professor I know. That wraps it up, Fred. Thank you so much.
A great pleasure, Andrew, as always, and I look forward to talking to you next week.
Indeed. Professor Fred Watson, astronomer at large, part of the team here at Space Nuts, and thanks to Hugh in the studio, who's made an appearance for the first time this year. Good on you, Hugh. And from me, Andrew Dunkley, thanks for your company. Looking forward to joining you again on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.